Hello and welcome back to the class of 5G. In previous lecture, we posed an important question that how does antenna discriminate between the intended user or the intended recipient and the other users who are also covered by the range of antenna? The answer is it doesn't discriminate. Yep, that's right. The antenna doesn't discriminate between the users. Then, how does our message find its intended recipient? The message delivery process has evolved over time in terms of security and efficiency. Let's take a look at how it used to work initially. As we mentioned earlier, the antennas don't discriminate between the users. So just like modulating the signal before sending it, the mobile phones also used to add a bit of their own data before sending signal stream or data stream to the antennas or to the towers. That extra bit of data was called RF fingerprint. RF fingerprint was an encoded piece of information which consisted a lot of details regarding the message, such as the manufacturer code of the mobile device itself, the RF module ID installed inside the mobile, the device ID, which means the instrument ID or the mobile phone ID, the battery ID, and user ID. First of all, let's not confuse device ID by manufacturer code, because manufacturer code remains the same among all of the devices produced by a single manufacturer. Let's say there are 5 phones manufactured by Motorola and 5 phones manufactured by Nokia. Then the manufacturer code of all of the Motorola phones will be same, but it will be different from the one used by Nokia phones. And user ID means either the telephone number of user itself or an encoded version of telephone number and other details of user. Now, how and why is this important? Well, mobile phones network towers deal with 2 kinds of signals. First is the control signal, whereas the other one is the data signal. Control signals are used to deal with essential processes of communication like establishing the link between the 2 users, etc. And while we are making the call or while we are connecting to the user, when we are not allowed to speak and what you hear is a ticking sound like at the call connection sound like toop, toop, yeah, like that. The mobile carrier towers are establishing a link between you and your intended receiver. Let's expand further on this. Due to this RF fingerprint, when you are sending a message to your carrier, the carrier is actually broadcasting it, which means that the message is received by each and every user within the range of the receiver's carrier antenna. But only the targeted user's phone or intended user's phone decodes it, whereas the other ones just let it go or filter it. The reason how and why that happens is, first of all, they might not even be connected to a call, which means that their demodulators haven't got a permission to decode your signal. And secondly, before the exchange of messages, the carrier takes your, means sender's information, adds receiver's information into it, and broadcasts a control signal message in a way that only the intended receiver can decode it. For everyone else, it will just be a noise. It won't matter at all. And while the connection is being established, the receiver is given an RF fingerprint which acts like a key to decode the upcoming streams of signals. Just think about it. It's just like a public lock. Everyone can see it, but only the authorized person has the key to access it. Of course, this process was far from being perfect. In fact, there was a popular case of a Japanese mobile phone instrument called Oki 900, which made it really easy to bypass this complete process and eavesdrop on whatever signal it wanted to, which, as you might have guessed, led to many security threats. To summarize this process again, when we are making the connection between sender and receiver, the carrier antennas let the receiver and sender know which band of frequency is going to be available for talking on both sides, which essentially means that receiver will be told which frequency to tune into, and on top of that, receiver will also get an RF fingerprint, which will add another layer of security to decode the message before demodulating it. And it's not just about security. If we don't have such a functionality, the whole wireless communication will turn into a complete chaos. Just imagine you making a telephonic conversation with someone and just start listening to random voices everywhere. Now that we have seen the action part to fulfill the intent, let's get a summarized overview of 1G. Firstly, the obvious one. It was the first generation of wireless communication. And no matter how flawed or how imperfect it was, this is where everything began. So 1G will always remain important to the history of wireless communication. The nature of 1G was analog, and it supported simplex, which means one-sided, half duplex, which means two-sided but one at a time, and full duplex. The minimum frequency used to transmit the signals was 150 MHz, which means that human voice ranging between a few hundred hertz was modulated onto 150 MHz or more. It commercially initiated in 1979 in Japan, and then it was followed by Denmark, Sweden, etc. As a fun fact, currently Russia is the only country which still supports 1G by one of its carriers. And basically, this was 1G. In the next lecture, we will take a look at the issues of 1G. Till then, happy learning, and I hope you have a nice day.